Hello friends and welcome to another video from the Advent of Code 2023 series. I'm trying to catch up with the remaining problems, and today it's time for problem number 20. So let's dive right in to it. I'll switch here to Visual Studio. I'll just add my new project there, which will be then day 20. And I will add also project for day 20 part 2. And all right, I didn't rename it correctly. So let's get started. I just copy pasted the previous day. So just delete everything here. And let's get started. So I will check the problem description here. So today's problem is regarding pulse propagation. I've already pre-read and have some idea on how to solve it, so I just summarize things. So first, there is a single broadcast module. That is basically, you have a set of modules, communication modules, which are wired together using cables, and you communicate using pulses. And there is a high pulse and low pulse. And the modules do something with that pulse and send it forward. So there are flip-flop modules, which are either on or off. And initially they are all off. And when it receives a high pulse, it is ignored. And if it receives a low pulse, it flips between on and off, and then sends appropriately a pulse forward. Conjunction modules are the ones that remember the type of the most recent pulse they received from each of the connected modules, and then based on that what they receive from all of them, then they send forward low or high pulse. And there is finally a broadcast module which sends the same pulse which receives to destination modules of that broadcast module. So finally there is initial button module, which just sends a single low pulse directly to the broadcaster module. So the input looks like this. It describes the modules and where they send their outputs, and then what happens next. So there is finally that the inf one is interesting one, I think. It's a conjunction module, inverter, yeah. So yeah, this describes just a lot of things, and I like these are just names, so I think it's the inf is not that interesting. And let me continue. Basically, the question here is, what happens how many high and low pulses are sent when we push the button 1000 times, and then what is the total number when we multiply those two values? So let's dive right in, and I will start with the parsing of the input first. And I will keep this open as a reference because I will definitely need it. The problem description this time is more complex than usual. So yeah, need to have this as a reference for sure. So first we have, we will be reading the inputs, and for each line we will be parsing it based on this part, and that part will be the cable going from the source to the destination. And we will be keeping track of all the modules, and we will represent the modules and different types of modules appropriately. So I think in this case it's worth creating some classes for things. Oh, what are you trying to say here? So let's do module. And it's gonna be pulse propagation, and let's module will be the base class of this, and it will then we will have a pulse type. Which will be kind of high or low enum. Then we will have a broadcaster, which will be a module type. And well, basically we'll do the same thing here for, what is the name of the flip-flop? Flip-flop, and it's gonna be a module, and it's internal actually. And finally there is conjunction, and pulse propagation module. So we have these three types of modules, with one base module which we can mark as abstract, and which the other ones will be overriding its methods. And then what we will want is to somehow count the number of pulses that are sent of different types. But basically each module will have process methods somehow. So it's going to be something like void virtual process pulse, and it will be processing the pulses that are sent. Virtual void, I mean. Okay, and it's going to be a pulse type. And also we need the source. So source module. Okay, so this will be processing the pulse. Yes, section abstract, and we also need to track the sources, the inputs of the module and its last state. Let's check here. So I'm just checking what's the initial state of the inputs, basically, if it's always low pulse here. Actually, no, we can create public abstract, or I mean virtual add input, which will be adding inputs. So we can do protected module, list of modules, inputs. So So this will be the inputs that we are getting, and we will be adding input module to that list. And that's it, I think. We will need, for each module, we will need its output, right? Because it's, okay, it can be multiple outputs as well. So, or rather, all these destination modules, yes. All right, so there's a single broadcaster which sends to all destination modules. And yeah, all of them can have multiple destination modules. So there can be a constructor that takes in or actually we need to, well, we will be using string as in the identification for the inputs, because we will not have instances initially. So instead we'll have string here outputs, and we will store those in a field. So that's going to be a protected one as well. And what else do we need? Yeah, we need the name, of course. So it's going to be a name. And that's going to be a public property. That's fine, I think. So what else? What else do we need? Or rather, make this also public, because we might need the inputs anyway, the outputs anyway. So let's make it public. I think the inputs can be private or protected, but this one should be accessible from the outside, quite likely. And finally, add input. We will add input module like this. Okay. All right. So that's it, I think. So now let's implement the individual types of inputs, of modules, I mean. So let's implement abstract class. We will create a constructor, which, or rather, we'll create a new constructor that takes in these same arguments, and now the process pulls. So let's read up the rules for broadcaster. I mean, here, broadcast module. If it receives a pulse, it sends the same pulse to all of its destination modules, right? So nothing too special. It just sends the same pulse to all destinations. So it doesn't care from where it comes, but it just sends it forward. So what we need also, that's quite important, we need some way to access the modules that are there. So what I think we can do is to have some static. For this simple case, we can do a static. So we will have static dictionary modules, and we'll make the constructor private. Let's do public static module create module, which will take in. All right, because we need. All right, it's not the right approach, but we'll just track the modules here. Just simply So yeah, that should be it. So now this field will store all the modules, and it's going to be a dictionary, so we can easily reference, get the module that we're talking about. So we'll do process, so send pulse, it's going to be output, and we'll send the same pulse that we got, and this method can be set here. So public void send pulse, and actually it can be a static one, and we will need it, we'll use it from the input. So send pulse to a target with we'll get the module and process the pulse, and yeah, we can make it instance based, right? Because we don't. Yeah, it's fine. Okay, so we send the pulse, and now that's the broadcaster. I think there's nothing special there. So it sends the pulse to all of its outputs. Then we have conjunction module, which remembers the type of the most recent pulse received from each of the connected input modules. So it needs to remember so it's going to have a last input pulses. Initially it's going to be all low, but we need to make sure that we override add input to also add that input module to that list. So we remember the last pulse that was there, and it says that when a pulse is received, the conjunction module first updates its memory for that input. And if it remembers a high pulse is for all inputs, it sends a low pulse, otherwise high pulse. So let's do for if last input pulse is all if all are high, then we send low, otherwise we send high. Okay, so it's actually the other way around. So pulse send, it's gonna be for most cases high, but although you can do actually like this. So if it's all high, then we send a low one, otherwise we send high. So if all are high, then we send a low one. It's kind of confusing, so I'm trying to visualize it. So high pulse is low, and otherwise we send high if any of them is not high. So that's I think okay. And we send the pulse to all outputs. Right. Right. Then there is finally flip-flop, and flip-flop has a state. So we implement the basic things. And then we need to remember our state. So initially off, so we'll do a private bool is on, which is initially false, and if it's on, So if it receives a high pulse, if pulse is high, then nothing happens. So this is basically what it says. If it receives a low pulse, it flips the state and then sends if it's on, if the new state is on, it sends a high pulse. If it's off, then it sends a low pulse. So if the new state is on, it says high pulse, and if it's off, then low pulse. And that's it, I think. So those are the basic module types. And now we will do something with that information. So we'll create we'll read input, so read all lines, and for each line we will not split it by this, but by this string. The name is, well, it's not the name, it can be some character, and it's gonna be either broadcaster, so designation, let's do designation, and part 1 will be, this is gonna be outputs, and the outputs will be separated by a comma and a space. So let's do it like that immediately. And now, so if a name or designation equals broadcaster, then we will create a broadcaster and it's gonna take the outputs, and we add it to the list of modules. Then we have this guy, which is else if. Let's do name equals designation substring 1, starting by 1, and we switch, and if it's gonna be flip-flop, then it's gonna be flip-flop, and if it's gonna be, what is it, second one, it's end. So it's gonna be, if it's end, it's gonna be conjunction. Create that module, and we do module, add module, and that's it. All right, you need to specify module here. All right, so we generate a proper list of modules. So we have all of them now read out from the input, and now we need to push the button. So we will take the button is pressed button for the button. Yes, so it's the button sends the low pulse to broadcaster. So what we need is to do something like this. And it's going to be how many times? We are pressing the button 1000 times. So we press the button. So we take module broadcast we do broadcast, and we will do something like modules broadcaster process pulse. Okay, so we will do pulse type low pulse. So we send specific pulse. It's gonna be always slow, but this is nicer. So pulse type low. Right. I think that's okay. And now what we finally need is to track the number of pulses that are sent. Or actually, I could have used. Oh, I don't have instance. So what I will do is send pulse broadcaster pulse. And it can be static. It cannot be static. I see. So module source. And we do this. Okay, that's better. So now, have I ever used this one actually? Oh, that's important. I'm not tracking the state here. And I can do this even. So module name, I will set it to pulse. And source module name. This one is not used. String source module name. All right, and finally here, string source module name. This might be better. So now instead of having this, I can do source module name and send it along. So now just fix these references. So name and name. Okay, is that okay? I hope so. And whoa, one important thing I think I remember. The pulses are processed in the order they are sent. So that's quite important. All right, so it's a queuing mechanism. So let's do something better, actually. And I will call it a machine. And this one will be a kind of container for all the modules. And that one will keep track of the pulses. And it's going to be the ideal way to track everything. Also, we can move now this, we can move here. So we add module and send pulse. Yeah. So module will this now will be gone, and we will be sending pulse by using the machine. Rather, I can even have this as the argument to this. So machine. So I will keep track of this as a field. Just a little refactoring, I would say. So I will do enqueue enqueue pulse. So source module target pulse. So this will be enqueuing the pulse to be processed. from the machine, and the machine will be, so this can now be completely protected. It doesn't have to be public. And this method I will create now. So we will create a static read-only queue pulse queue and queue that pulse. All right, so I think that's better now. So we're enqueuing those pulses, and there will be terminal void pulses method, which will process the pulses that are unqueued. So while pulse queue count will be the queuing and sending the pulse to the destination module. And that's it, I think, yeah? So now let's adjust this again. So instead of adding the modules this way, we'll create a machine. So machine, new machine. We'll add the modules to the machine, which is instance based. So nothing like this. And we will then send and queue the pulse of low from button to broadcaster with low. And now when we do this, we will process pulses. All right, I hope this is okay now. And what I will do, I will try to run it. There are some issues. So what is it complaining about? Did I forgot? Yeah, the machine itself. Yeah, machine. I added the new parameter and didn't add it to the list, so we need to do that for all three types of modules. And finally here. Right. And something's wrong here. Yeah, right, of course. Machine. And run it. So now this should be, yeah, this ends properly after 1000 presses, but we are not yet tracking the number of send pulses. So what we need is also to track it here. So I will do something like so maybe public int low pulse count, high pulse count, something like this, and we will be counting those here. So if pulse low and high, so in the end, when all of this is processed, we will be having the total number in those properties. So now we can do times machine high pulse count, and hopefully, if we're lucky, we'll have the right numbers there. Well, 8,000, 4,000. Yes, that's correct. So let's see if that. So it gives us the right number. I'm just want to make sure that we are not doing the same mistake as last time. So I will immediately make it long because you never know. So let's do long. And let's try a more complex input. So I will try. I'll try the second example that we have here first. So that's a more interesting number, and we have a slight miscalculation there. A slight miscalculation. So thousand times. Okay, so there's something not completely correct here. So let's go to this place and let's see what happens. So 20. One more than it's supposed to be. And one less than it's supposed to be. So I'm missing one pulse somehow. It's very interesting that I'm missing just exactly one pull. I have one misplaced pulse. Oh, right. That's important. I'm missing. There can be a module that does not have any output. A module that is not there actually, but has a name. So the machine has to be able to process it. So, I mean, enqueuing should be fine. You are enqueuing the pulses. That's interesting. It's really interesting. I'm trying to find out what's going wrong there. Why is there just one mismatch? This is one. This is okay, but what is wrong there? this is fine, but is it the output that somehow is a problem? We are tracking the numbers during enqueuing, so it should not matter. So I can do something like this: if target equals output, then return. But this is not gonna work at all, right? That is completely different number. So, and that's not the problem. All right, so let's go back here. Q. So after this, we have one more low, one less high than we're supposed to have. It's really interesting. If it was a bigger difference, I would be less surprised than this, because this is just a very small difference, and that means that we are missing something very small somewhere, and that's usually hardest to find. When we're enqueuing the pulse, we're already counting it properly, so that's not a problem. We're enqueuing source module name target pulse, so that's not a problem. We're sending it properly, so that's okay as well. I mean, I can do something like this, but I think this is gonna fail only for output. Yes. So why is it not tracking that one single additional pulse? I can try the big input, but I think it's gonna fail fail the same way. So it's probably not gonna work. Yeah, it's too high. So that is something I'm missing. So something basic, probably. So let's do. Are we actually? Oh, this is pretty important, right? Because I'm not adding inputs. Ah, that's it. That's definitely it. That's definitely it. So once more, let's take this input, because I was not tracking the inputs, which was not a problem for most of them, but it's a problem for this one. So what I need is after we add all of those into the machine, I need to go add inputs. It's going to be this code will be adding the inputs for all of them. So modules, each module, we will be adding, okay, so for each modules, we'll be adding so for each output, we'll be adding the target as an input. That's probably gonna be it. Yes, now it's correct. And I think that might work for my big input as well. Right. Let's see. And that is correct. Okay, so we have the first part of the problem solved after a small blunder. I'm not sure why I didn't notice that the method wasn't actually used, but now it's done, so we can switch to the second part. So now for the second part of the problem. I've already pre-read that part too, and the weird thing, unfortunate thing is that in this case, again, the solution kind of depends on how the input looks like. So the thing is that the question that we are asked about is how many times we have to push the button to get a low pulse to module Rx. And if we check the input, we can see that the Rx module appears there only once in the whole list. And input of it is a conjunction module Mg. And to get a low pulse into Rx, the conjunction module must send a low pulse, and conjunction module sends a low pulse whenever all its inputs send high pulses, or the last input from them is high. So to get there, we need to check for all of the inputs of Mg, when do they send a high pulse, and then find a lowest common multiple of those, because this is gonna happen regularly in regular intervals, in regular number of button presses. So we need to calculate how many times, how long are those loops or cycles for each of those inputs, and then find the lowest common multiple of those to get the number of button presses it takes to get all of those aligned to be high, so that the Mg, in my case, sends the low pulse to Rx. So let's try to do that now. So I will adjust my machine a little bit, because currently we're pressing the buttons here, and we don't have any way to see how many button presses we have done already. So my goal here is to change this to be while true instead. Then we can do machine, like get that ng module. I get the module somehow, so I'll do a indexer maybe to a machine. So we can do, no, we want to add an indexer. Yeah, there is no intelligence to it, so I can do it here. So public module. So kind of just getter for the module. And what we will do is we will turn this into a method. So I'll take this out. We'll do machine press button. And this will be a new method that will do exactly what we have done here, just encapsulate it in the machine itself. And it will count the number of presses. So that will be public int button press count, and this will be increased every time. So this tracks the number of button presses, and what I want to do is to track for the MG. I want to track the number of presses it takes for each input to be true. So, or rather high. So what I can do is I can do dictionary string int high pulses, and this will track the number of presses it takes to get the high pulse for each input. So if pulse equals high, and if high pulses, if it doesn't contain that value yet, key source module name, then I will do actually I don't have access to, or I do actually. I have a machine, or rather the machine should be protected so I can access it. So I can do machine button press count. So I store the number of presses it took to get there, to get that specific high pulse for that module, and then what I can do is to check if high, or rather I need to cast it to conjunction, and I will do high pulses if high pulses count equals, and how many inputs are there. Well, I can do so public int, or last input pulses dot count rather. So the number of pulses I did for that button. So if that works, then I will break. And now we know the number of presses for each of those inputs, right? So if I run this, I should be able to get high pulses, some numbers there, right? And now what I need is to get lowest common multiple of those. So let's ask AI to do this. Get lowest common multiple of the high pulses. Well, this is not gonna be it, right? Because it's not gonna be the number. So I will do long LCM and the GCD as well. So this will be greatest common divisor, lowest common multiple. Hopefully it's correct. I will not check it. And I will do exactly this. So get the LCM, and hopefully the number that we get is the correct one. Well, let's see. And it is. Okay. All right. I was afraid of this one, but in the end it wasn't that horrible. But again, it was a problem that depended on having the input in the right format, which is not something I generally like, because it means that you don't have the general solution, which is usually nicer. So yeah, but good thing is that we have the solution, and we have now passed day 20 of Advent of Code 2023. I have 5 more problems to go. I will be hopefully doing more videos soon, but I will also make a new video on this same problem solved by ChatGPT. Also, we'll see if it solves it or if it just gives up, because I think this is going to be complicated, because it will not be able to recognize the format of the input, and will not be able to see that it has to understand the input so that it can solve the problem efficiently. So we'll see. I thank you for tuning in. If you want to get notified about new videos, please subscribe, and I will see you in the next video. Bye bye.